Hi, in this tutorial, we will learn about the direct pathway, right? The direct pathway. In the last tutorial, we have learned the normal anatomy of the basal ganglia, the structure it involves, right? So here we have the cortex. Yes, this is the cortex. Here it's the striatum. This is the striatum. The striatum is caudate nucleus plus putamen, right? Together makes striatum. And then you have globus pallidus. This is your globus pallidus, okay? This is your globus pallidus. And the globus pallidus has two parts. One is interna and the other one is externa. And then we have the structure here, the subthalamus, and we have the structure here, substantia nigra. These are your basal ganglia's nuclei, and there is one more structure here, which is the thalamus. Thalamus is not part of the basal ganglia, but it's very important structure, so we have to include it to learn about the direct pathway. So we need the thalamus, okay, and the cortex as well. Right. So the direct pathway. Here we have the fibers that's coming from the cortex. I will draw it in green. Now, the green neurons, they are glutaminergic. They release the glutamate, which is stimulatory, and which in our lecture we will represent by the plus sign, which means stimulation. And the glutamate are these dots. It will represent the glutamate, right? And we have the subsequent neuron, which I will draw in red to represent the GABAergic neuron, right? They are the GABAergic. They are inhibitory, which we will represent by the minus sign. And these dots, the red ones, should represent the GABA, okay? So the direct pathway, okay? Now in direct pathway, these neurons, they are longer. Now this one from the cortex down to the striatum is called corticostriatal fibers, right? And from the striatum to the pallidus, the pallidus interna, it's called striatopallidal fibers. And from the globus pallidus interna to the thalamus are the other neurons or the fibers called the pallidothalamic fibers, right? Which are also GABAergic. And then we have these green neurons in the thalamus that will send the signal to your cortex, okay? Now these neurons, they are called the thalamocortical fibers, okay? These are the name of these different fibers. So this is your direct pathway. When the direct pathway is not stimulated, when there is no intended action or there is no task and you're at rest, there is no stimulus to these neurons and there is no action potential coming down to release the glutamate here and stimulate these neurons in the striatum. So when you're at rest, no glutamate, and when there's no glutamate, no stimulation, no action potential down here. Since these neurons, they are inhibitory, so they will normally inhibit these neurons, and when these neurons are inhibited, this will be stimulated. But at rest, when these neurons are not stimulated, there will be no GABA released here in the globus pallidus interna on these neurons. When there is no GABA release, now these neurons will be released of inhibition. When they are released of inhibition, they will become excited, okay? They will become excited, right? And when they are excited, the action potential, these positive signs should remind you of action potential, and it will flow down here when the action potential reaches here, and it will release the GABA, which is inhibitory, right? So the GABA will be released on these neurons. When the GABA is released, it will inhibit these neurons, and there will be no action taken, or when you are at rest, that's what happens, okay? But when you are not at rest, let's say when you are not at rest, what happens, okay? The stimulus will come from the cortex, and it will stimulate these neurons, right? When they are being stimulated, the action potential will flow down, okay, all the way down, and it will stimulate these neurons because the glutamate will be released. When there is glutamate released, these red neurons, they will be stimulated, and the action potential will go down to inhibit the consequent neurons, because when the GABA is released here, there will be a lot of GABA released. What happens to the neurons? The GABA will be released, and these action potential will not flow, and when the GABA is released, it will inhibit, right? The GABA will inhibit these neurons, okay? When these neurons are inhibited, there will be no GABA down here, right? There will be no GABA here. When there is no GABA, you will not have those neurons inhibited, so the neurons in the thalamus will be excited. They will be excited, and the action potential, they will fire, and the action potential will flow in this manner upward to the cortex. When the action potential reaches here, the glutamate will be released, right? When the glutamate is released on these neurons, okay, it will stimulate these neurons. And then what happens next? These neurons will send signal down. Let's say these neurons, they go down here, right? So when the neurons, they come down, let's imagine that these neurons, when they come down here, okay, when they come out here, they will either stimulate your cranial nerves, or they will go down to the spinal cord to send the peripheral nerves and stimulate muscles, and the muscles will do the intended action. Let's say the direct pathway, it stimulates the agonist muscle, right? Now these agonist muscles are, let's say, flexor muscle, to do the action and flex your muscle. So this is your direct pathway and how it works and stimulates, okay?